Hello everyone. Today I'm going to show you how to find the least common multiple or the LCM of a set of numbers using a step-by-step process. Now these steps can be used to find the LCM of any set of numbers, small, large, few or many. You can use the same process to find the least common denominator or the LCD when performing addition or subtraction of fractions with unlike denominators. And you can use the same process in algebra to find the LCM or the LCD of algebraic expressions. Now I've written out the steps here, but I want to work through some examples demonstrating how to apply these steps to find the LCM. So I'm going to begin with a relatively easy set of numbers, 6 and 4. So I want to find the LCM of 6 and 4 using these steps. So let's read step 1. Step 1 says factor all numbers in prime. So I'm going to take the first number we have here, 6, and factor it in prime. So the factors of 6 are 2 and 3. 2 times 3 is 6. Now you may say 1 is also a factor of 6. Why don't we pick that? Yes, 1 is a factor of 6. However, I'm leaving out 1 because in the final step when we find the LCM and when we multiply the different factors, 1 won't make a difference in the multiplication. That's the reason I'm leaving out the 1. Okay. Let's do the next number, which is 4. The factors of 4 are 2 and 2 in prime. Okay, so that completes step 1 for us. We factored both the numbers whose LCM we are trying to find in prime. Okay, next step says write each factor in exponent form. So let's do that. Now 2 as a factor of 6 occurs once. So I'm going to write that in exponent form as 2 to the power 1. Likewise, 3 as a factor of 6 occurs once. So I'm going to write that as 3 to the power 1. For 4, 2 occurs twice, right? We have 2 times 2 as the factors of 4. So that occurs twice, so I'm going to write that as 2 to the power 2. Now we have written all the factors of 6 and 4 in exponent form. So that completes step 2 for us. Now we go to the final step or step 3 to form the LCM. So to form the LCM, we pick each unique factor with the highest exponent and multiply them. So let's do that. To form our LCM, we pick some of the factors, not all. Which ones do we pick? The ones with the highest exponent. So of 2 to the power 1 and 2 to the power 2, the one with the highest exponent is 2 to the power 2. So I'm going to pick that. Each unique factor. Therefore, 2 to the power 2, each unique factor with the highest exponent. And there's only one 3 and its highest power is 1. So I'm going to pick that. So I'm going to write 3 to the power 1. And now I'm going to multiply it out. So 2 squared is 4 and 3 to the power 1 is 3, which when multiplied gives us 12. Therefore, the LCM of 6 and 4 is 12. Now, let me tell you a concept about the LCM. The LCM should be the smallest number that is divisible by both 6 and 4. Or in other words, the LCM should be the smallest number that should be divisible by all the numbers whose LCM we are trying to find. So in this case, the LCM of 6 and 4 is 12. Therefore, let's do a test to see if 12 is divisible by each of these numbers. So is 12 divisible by 6? Yes. 12 divided by 6 is 2. Is 12 divisible by 4? Yes. 12 divided by 4 is 3. Therefore, it satisfies that condition that the LCM should be divisible by all the numbers whose LCM we just found. Right? Let's do another example of a slightly larger number. So let me just erase this, and we'll work with again two numbers, but they'll be a little bit larger than what we just worked with. So I'm going to pick 12, okay, 12 and 18. Same steps, let's follow the same steps. It says factor all numbers in prime. So let's start with 12. Right? Factors of 12 in prime are 2 times 2 times 3. Okay. Now, you may say that 4 and 3 are factors of 12 as well. However, 4 is not a prime number, therefore I had to break it down to 2 and 2 so that the numbers are all in prime. So 2 times 2 times 3. The next number we have is 18. So let's factor that in prime. So we will have 2 times 3 times 3. Again, 2 times 9 is 18, but 9 is not a prime number. Therefore, I broke it up into 3 times 3. Let's do step 2, where it says write each factor in exponent form. So for 12, the factors of 12, 2 occurs twice, so I'm writing it as 2 squared, or 2 to the power 2 times 3 to the power 1. For 18, 2 occurs once, so I'm writing it as 2 to the power 1 times 3 squared, or 3 to the power 2. Now we come to step 3, where it says to form the LCM, pick each unique factor with the highest exponent. So let's pick our factors to multiply. Each unique factor with the highest exponent. So of 2 to the power 1 and 2 to the power 2, we pick 2 squared, or 2 to the power 2, because that's the one with the highest exponent. So 2 squared multiplied by, of the 3's, 3 squared is the one with the highest exponent. So I'm going to write that 3 squared. And then multiply that out. 4 times 9, 3 squared is 9, is 36. And that's the LCM. Again, you can always do a check to see if the LCM is divisible by both the numbers 12 and 18. So 36 divided by 12 is 3. And 36 divided by 18 is 2. Let's do that. 36 divided by 12 is 3, and 36 divided by 18 is 2. So that satisfies the condition that the LCM should be divisible by all the numbers whose LCM we just found. I'm going to show one more example with 3 numbers. However, I'm going to just add one more number to the existing 12 and 18. Okay, let's do that. I have to erase it and add one more number to find the LCM. So let's find the LCM of 12, 18, and the third number 48. So we've already found the we've already worked out steps 1 and 2 for 12 and 18. We need to do the same for 48. So I'm going to write here 48 and work steps 1 and 2 for 48. So step 1 is to factor all numbers in prime. So for 48, the prime factors are going to be 2 times 2 times 2 times 2 times 3. 16 times 3 is 48. You can always verify that. So 2 times 2, okay, 2 times 2, 4 times 2, 8 times 2, 16 times 2, times 3 is 48. All right. So we have 4 2's when writing in exponent form. We have 2 to the power 4 because we have 4 2's in 48 and 3 to the power 1. Okay, so now we got everything in exponent form. All the numbers have been factored in exponent form. So let's do the last step to form the LCM. So the LCM of 12, 18 and 48 would be of the 2's, 2 to the power 1, 2 to the power 2 and 2 to the power 4. We pick 2 to the power 4 because that's the one with the highest exponent. And of 3 to the power 1, 3 to the power 2 and 3 to the power 1, we pick 3 to the power 2. That's the one with the highest exponent for 3. And now we multiply them out. So 2 to the power 4 is 16. 3 squared is 9, which when multiplied gives us 144. You can again do a check to see if 144 is divisible by 12, 18 and 48. 144 divided by 12 is 12. 144 divided by 18 is 8. 144 divided by 48 is 3. Okay, so that again satisfies the condition that LCM is divisible by all 3 numbers. I'm going to leave you today with a little homework for you to check if you have followed the process and if you are able to apply all 3 steps to find the LCM correctly. So your homework is to find the LCM. Okay, find LCM of these 3 numbers, 24, 35 and 45. Now I'm going to give you the answer should be 2520. The LCM that you find of 24, 35 and 45 should be 2520. However, I would like you to apply these steps on these numbers and see if you are getting this answer 2520 for the LCM. And I would like you to let me know in the comment section which factors with what exponents you picked in order to form this LCM of 2520. All right. Thank you very much, and I'll see you in another video in the future.